Elastic Cloud Compute was launched by Amazon around 2006 as the premier service to solve computing needs. It has since become the foundational building block for most applications utilizing AWS, as well as the basis for many other services. Amazon has added many features to EC2 over the years, expanding its usefulness, and today it is a robust tool that fits an impressive number of use cases. So, what can you do with EC2 instances? Well, the answer to that question is almost as nebulous as asking what you can do with a computer. In many ways, an instance is basically a computer. You can use it to run an application, be it a web application or local. You can log into the instance and use it like a remote virtual machine. EC2 instances can have very specific types of software installed on them to do all sorts of tasks. Basically, computing. I know that word can mean almost anything, but that's really what EC2 is about. It is an endlessly versatile resource that can be used for whatever you need to use it for. Now let's take a look at the technical specifics of EC2 and how it really works. First, let's break down the name Elastic Cloud Compute, since it provides some insight into how the service works. Cloud compute should make sense based on the last module. EC2 is a service that can be used for computing purposes like running an application, and it's located in the cloud. In other words, not your closet. The elastic term in EC2 is much more interesting. Elastic means that the computing service can expand and retract as needed. I've mentioned this action before when we discussed scalability, but EC2 is very convenient in this respect due to the fact that rules can be set so the scaling up or down happens automatically without you having to do anything manually. We'll talk about this more with auto-scaling groups. The basic building block in EC2 is an instance. An instance is essentially a virtual server which is operating system agnostic. To illustrate the different aspects of EC2 instances, I thought it might be simplest to just walk through the creation of an instance. There are several options that are configurable with each instance, and you'll need to make decisions with each of these whenever you create an instance with EC2. The first is the image for your instance. This is the fundamental code that will be running on an instance. This is not your application code. Let me give some examples to further explain. Here are the Amazon machine images currently available when you create a new EC2 instance through the web console. At the top is Amazon's own flavor of Linux, followed by Red Hat Linux, SUSE Linux, and Ubuntu. Microsoft Windows is also available, and you can see that there are different versions of everything mentioned easily available. So you can see that an image is a combination of an operating system and then some applications pre-installed, typically things like Java or Python or the AWS CLI tools. Amazon provides, manages, and updates a selection of images that are available. Updates are important to patch security vulnerabilities that are found regularly throughout the year, and having Amazon and their knowledgeable security teams handling this responsibility provides good peace of mind. Just a caveat, however, once an instance is created with an image, Amazon won't be updating that instance's software. They just update the available image. If you need to update your instance for security patches, you'll need to either manually make the updates or create a new instance and migrate any application code. The Amazon provided images are just the beginning. There's also an AWS marketplace that gives anyone the ability to provide images that you can install easily. Some images are full applications provided by vendors that you can use off the shelf. Some examples are enterprise firewalls, security applications, and content management systems. There's even a subscription model in place for images that vendors can utilize to charge users of their software. The community can also upload images for open source software such as MongoDB or the MeanStack. When using some type of open source image, you'll only need to pay for the hardware that the image is running on. Once you've selected an image for your instance, the next decision is to select the instance type. This is essentially the specs for your instance, the number of CPUs, the amount of RAM, and the network performance. With these three options, Amazon has created instance types and families. Families provide an easy profile to help decide the right type for your use case. Running a file server, an instance from the storage optimized family might be best. Doing some machine learning, the compute optimized family might be your best choice. Within each family, there are types, like small, medium, large, extra large, etc. To give you a concrete example of what I'm describing, let's compare the large instances in the general purpose, memory optimized, and compute optimized families. The general purpose large instance provides a balance of CPU memory and network performance. We can use it as a control group here. The memory optimized large instance has the same number of CPUs as the general purpose instance, but twice the memory. On the other hand, the compute optimized instance provides the same number of CPUs as the general, but cuts the memory in half. You might think that makes compute optimized the lesser of these, but with a difference in features comes a difference in price, and the compute optimized family instances are the cheapest of them all. As you can imagine, increasing the type from large to extra large or down to medium will give you more or less of each feature at an equivalent ratio. It's important to consider the best instance type for your application. It can not only help your application perform better, but it can also save you a lot of money. Once the image and instance type have been decided, you're provided with a page of instance details that relate to security roles and further fine-grained configuration. Although many of these are important, we'll just talk about the number of instances field. This is a place that you can assign a certain number of instances to replicate with this same image and type. AWS will create an auto-scaling group that will increase or decrease the number of instances according to rules that you set yourself. Once the auto-scaling group has been created, you can modify it further. If you're working with a third-party image or one you made yourself, this is the perfect way to set up scaling. If you're curious about how to have an application that you've installed on an instance configured to auto-scale, this is actually easiest to accomplish with the application service Elastic Beanstalk, and there'll be more on that in the next module. The next step is to add storage. Storage is conceptualized by the term Elastic Block Storage. This is essentially a storage service that makes it easy to reason about and calculate charges for storage. These volumes live independently from your EC2 instances and can be retained or deleted when the EC2 instance is terminated. As a note, Elastic Block Storage is not the same as Simple Storage Service, which we'll cover next. Elastic Block Storage is specifically for using with EC2, whereas S3 is for both storing and serving up independent files. In this menu, you can add volumes and adjust the root volume size for the Elastic Block Storage volumes attached to this EC2 instance. We'll skip over tags, which are just meta values you can add to the instance for your own purposes, and then we come to the security group configuration section. If you remember from the last module, security groups can be thought of as little firewalls configured at a per instance basis. Put simply, a security group controls which IPs your instance can talk to and which IPs can talk to it. For instance, it's not a good idea to leave your instances open to SSH sessions from anywhere, so it might be good to only allow incoming SSH sessions from your current IP address. You could also allow your instances to talk to each other, or say a database, or accept incoming requests on port 80. There are many different ways you can use security groups, and once they're created here, you can edit them and add more rules later. The final step is to create the instance with an existing key pair, which will allow you to SSH into the instance and make whatever modifications you want. You can also choose not to use a key pair if there is an existing application on the instance image that will prompt you for a password. Now that we've covered most of the basic configuration options, let's talk about the pricing structure for EC2. Any actual numbers will likely have changed by the time you're watching this, but hopefully the structure will be the same. Amazon charges for EC2 instances by the hour, and the amount per hour differs based on the instance type and image that you've selected. Some images, like a Windows image, will cost more than a Linux image simply because the image software must be licensed and paid for by Amazon. Let's look at the pricing of a large memory optimized instance running Amazon's Linux image. The per hour rate is 16.6 cents, which gives it a daily rate of a little under $4 per day. You pay only for what you use, so you can start and stop the instance whenever you want and only pay for the time it was alive. $4 per day might be a little steep for your case, so let's look at one of the most basic offerings, a general purpose T2 micro instance. This instance type comes with one CPU, 1 gigabyte of RAM, and costs 1.3 cents per hour, which adds up to around 31 cents a day. Now we're talking. For a month, that's around $10, which is fairly reasonable. Amazon has many options for pricing. I was only talking about on-demand pricing. There are other models like reserved instance and spot instance pricing that both offer lower prices than on-demand pricing. It can all get a little confusing, I know, which is why the AWS calculator is so useful. Also, keep in mind that Amazon offers a free tier of usage for many services. With EC2 in particular, you currently get 750 hours of T2 microcomputing per month for an entire year. This should be enough free usage for you to get your feet wet with the service. One last note with pricing in regards to EC2. The Elastic block storage that your EC2 instances use has a separate charge associated with it. 10 cents a month per gigabyte for general purpose SSD volumes. There are currently no additional fees for auto-scaling, but an additional load balancer or Elastic IP do cost extra. Just keep these in mind when calculating a total cost for your EC2 usage. There's plenty more to EC2 instances than what we have covered, but this should give you a great overview of how EC2 is presented and what you can do with the service. EC2 is actually used under the covers for other services, like the relational database service we'll cover in this module, so it's a good idea to become comfortable with managing and configuring these instances.